So in my last video, when we were talking about quantum mechanical model, we talked about Schrodinger's wave equation. If we remember, let's remind you. It was d xi square upon dx plus d xi square upon dy plus d xi square upon dz plus 8 pi square m square upon h plus e minus v xi is equal to 0, right? So this is Schrodinger's wave equation, where xi square is the probability density of electron. So we came to know that when we solve this equation, we got, like, in the result there were 3 variables, and that variables were named as quantum numbers, and the S quantum number was introduced after that. It was discovered after that. So now, when talking about shape of atomic orbitals, whenever the value of xi square is highest, like almost 90%, that region is known as orbital. So an orbital is the region of space around a nucleus within the probability of finding an electron of a given is maximum about 90%. The probability at any point of around the nucleus is calculated using Schrodinger's wave equation. So whenever the value of xi square is highest, like 90%, that region, that space is known as orbital. But what when the probability of finding density of electron is 0? Like, what will happen? This is known as node or nodal plane. That is known as node or nodal plane. So what, whenever the probability density of an electron is highest, like at 90%, that region or that space in the atom is known as orbital. But whenever, like, there is 0, that is known as nodal plane. So now let's talk about orbitals. Let me remove this. So now let's talk about S orbital. The shape of S orbital, right? So the shape of S orbital is spherical. So now let's draw the axis first. Okay, let's take this color. Okay, so this is spherical, right? For example, I'm taking this one where this is another. Here you can see this. Let me draw another one, then we will come to an end. Okay, we are done now. So this is 1s, this is 2s, and this is 3s, right? As you can see over here, yes, so this is, there is no node over here. What was node? Like the where the probability of density electron, probability density of electron is 0, but here it is not 0, like you can see over here. But you can see over here, this is 1s, but there are, we're talking about 2s, like shell number 2. So obviously the 1s will first come, then 2s will come. This is also s, but the space here, this is known as node, because you can't find electron over here. You will find that electron can revolve can find electron can revolve here. Electron can revolve in that blue region too, in that 2s shell, but it won't revolve in this region. So this is known as node, where the probability density of electron is 0. Now let's talk about 3s. Right, here you can see this is 1s, so here the probability density is greater, but here this is node, right? This is 2s, right? And this is again node, and I forgot to draw shell number 3. Okay, wait a minute. So here this one is 1s, right? This is again node, this is shell, again 2s, this is again node, and this is shell. So you can find that there are nodes that where the probability density of electron is 0. It is known as node. And you can observe the slide also, observe the size of the s orbital, like 1s, 2s is greater than 1s, and 3s is greater than the 2s. So you can easily find that the 3s is greater than the 2s, and 2s is greater than the 1s. So now let's talk about nodes. So basically we'll talk about nodes now. There are two types of nodes. First is known as radial nodes, or you can say spherical nodes, and second is angular nodes. So these radial nodes are also known as spherical nodes, right? So in the s orbital, for example, this is s, right? It is equal in all directions, okay? So here you will only find the spherical node, but you won't find the angular nodes over here. So let's look like what's the formula of finding the nodes. So the formula for finding spherical node is, let me take another color, okay, n minus l minus 1. So n is principal quantum number, and l is azimuthal quantum number. So n is principal quantum number and l is azimuthal quantum number. For example, let's find out the spherical nodes of 2s, right? N is 2, minus l will be 0, minus 1. So 2 minus 0 is 2, 2 minus 1 is equal to 1, right? So it means that there is one node in the 2s, right, and which is spherical. Now let's find out that how many nodes are there in 3s, right? So the shell number is 3 minus L azimuthal quantum number is 0. Like for S it is 0, P it is 1, D it is 2, and F it is 3, right? And minus 1. So 3 minus 0 is 3, 3 minus 1 is equal to 2. So there are two spherical nodes in 3s. In 2s there are one node, there is only one node which is spherical, right? But in 3s there are only two. So let's state. So the xi square gives the electron probability density of electron at any point, right? The probability of 1s electron is found to be maximum and near the nucleus and decreases. You can see that the probability of 1s electron is found to be maximum near the nucleus, right? And decreases as the distance from the nucleus increases. You can see the distance is increasing, right? So that's why the probability density of electron is also decreasing. But in case of 2s, right, 2s electrons, the probability is again maximum. Like first it was maximum, then it came far from the nucleus, right? So that's why the probability density of electron decreases. But again, it's again maximum near the nucleus and then decreases to 0, and increases again and then decreases as the distance from the nucleus increases. Okay, electron. Okay, now let's talk that here. Let me draw this one, right? This is S orbital, right? Let me color this. So this is non-directional. Why I'm saying that it's non-directional, I'm not good at drawing, but I'm trying my best in order to explain you. So it is non-directional. Now how I'm saying this is non-directional, you can look over here that it is equal in all directions. Like it is moving to all directions. It is not moving in a particular direction. Like in when we will talk about p orbital, it is directional because it moves in particular direction, in either in x-axis, in y-axis, in z-axis, whatever the axis is. But here it is non-directional. So this s orbital is non-directional. It has only spherical nodes, right? And the formula of spherical node is n minus l minus 1, where n is principal quantum number, L is azimuthal quantum number, and 1 is obviously a natural number or a whole number. I hope you understood the atomic orbital S.